148, a Strobogrammatic number 3. And this problem is based on the Strobogrammatic number 2. And if we know how to solve the problem 2, definitely we can solve this problem. Yeah. So we are giving two strings with low and high. So that's going to be the difference. And this low is going to be less than or equal to high. And we're going to return the number of Strobogrammatic numbers in the range low and high. So for example, from 50 to 100, it's going to be 3, and from 0, 0, it's going to be 1. Yeah, because it's going to be 0 for this case. And if it is 50 and 100, and maybe we can find 88 or 96 or 69, so it's going to be 3. So this is why it's going to be 3. So I'm going to use the result from the problem 2 to solve this problem 3 here. Yeah. So this is going to be the problem 2. I just want to copy and paste because I don't want to explain explain it, because if you want to check what happens for problem 2, you can check my video, Strobogrammatic number 2. And this is basically a backtrack function. And according to the problem 2, we are going to return something like we are giving this number n. This means the length of the string. So we are going to return all the possible cases. So for example, n equal to 2, we're going to return 4 different cases. If n equal to 1, we return 3 different cases. Yeah. So this is the meaning of the DFS. So we are giving this number n. So for example, n is the length of the string. So for example, if the length of the string is equal to 3, definitely we're going to return all the different cases for the string width equal to 3. For example, it can be a 111 or it can be 888. Yeah. So we just want to control the lower length and the higher length of the two strings, and we want to check the numbers if this number is in between 50 to 100. If it is in between, so we're going to count it as 1, otherwise we will not count it. Yeah. So this seems everything should be easy. If we already know how to calculate the DFS n. So basically this n is the length of the string. Now let's just prepare low and high. So I'm gonna use I'm gonna use n1 and n2. It's gonna be length of the low and length of the high. So definitely n1 should be less than or equal to n2 according to the problem, according to here. So the lower length should be less than or equal to the higher length. Yeah. Now what we can do is that we're gonna check all the possible cases, right? So for any number n inside the range of n1 to n2 plus 1. So this is going to be all the possible cases of the length. So for example, the length is 2 here, the length 3 is here. So we're going to check all the possible lengths of 2 and 3, and we want to check if it is in between. Yeah. So we want to check if the integer of low should be less than or equal to should be less than or equal to, and we should also check all the numbers inside this DFS. Yeah. And for any number inside the DFS, we're gonna call this yeah. So this is gonna be all the different cases, and now we're gonna check this number and we're gonna turn it into an integer. Maybe we want to use s as a string, and we're gonna turn it into integer. If it is less than integer of high and more than or equal to integer of low, definitely we're gonna count it as a result. Finally, we're going to return this result. Yeah, so the result from the beginning are going to be set to 0. Yeah, so from here, let me just delete here. Yeah, so from here, this part I think is going to be the difficult part. This is just according to how we're going to think about the problem. If we just fix the length of the string, it's going to be easier for us to solve by using the backtracking. Now we just use a brute force to check all the possible cases. So from the n1 to n2, we're gonna check all the possible cases of the length, and we're gonna check all the integer of those numbers. If it is more than or equal to high, low, less than or equal to high, we're gonna count it as 1. Now let me submit it and run it to check if it works. Now as you can see, it works and it's pretty fast. Now let's analyze a little bit about the time complexity. So here is just a for loop. So maximum is going to be something like 14, because 15 minus 1 is going to be 14 different cases. And here is for s inside the DFS. So basically the time complexity is like 14 times, because for each of the DFS there are going to be 5 different cases. Because if there are 2 numbers, it's like 1 1 0 0 8 8 6 9 9 6. So for each of the cases there will be 5 different cases. So how many cases? It's going to be 15 different cases, but 15 needed to divide it by 2, because for each of the time we're going to add 2 numbers according to our DFS from here. Yeah. So the final time complexity, we can still print it out, the final time complexity. So it's going to be 14 times 5 to the power of 15 and divided by 2. If we print out this number, we can see it's going to be a small number. That is why it works. Yeah. So if we check this number, it's going to be something like 2 times 10 to the power of 6. So basically, if the time complexity is something like 10 to the power of 6, definitely it works. Yeah. So that is why it's so fast. I think that's all about it. Thank you for watching. See you next time.